Hey guys, this is day 9 classwork for unit 6.2. So now what we're going to do is we're going to solve, let me get back up here to the thing. We're going to solve logarithmic or exponential functions when the base is not a common base, okay? All right, so we're going to start with problem number 3. All right, so this time we're going to go the opposite direction. So we're going to identify the base, the exponent, and the argument, and we're going to change forms this time. So remember, this unit is all about going from exponential function to logarithmic to exponential. So we're going to change forms. And we're going to put log base 2 of 61 equals x. Now, we know how to change this. We know how to change that with our change of base formula that we have. Remember, it is the log of the argument over the log of the base. So, log of 61 over log of 2 equals x, and we're going to put the log of 61 in our calculator. So I'm doing it just like you are. So we're going to put the log of 61 in the numerator, and we're going to put the log of 2 in the denominator, and we are going to round to 4 decimal places. So 5.9307, and that is our answer. And again, as long as the argument doesn't equal 0 and the argument doesn't equal a negative number, we're good. So that one's perfect. All right, let's try number 4. Again, the base is 8. The exponent is m minus 7. The argument is 92. We're going to change forms. So it is the log base 8 of 92 equals m minus 7. All right, change of base formula, log of 92 over log of 8 equals m minus 7. So in our calculators, we're going to hit the log of 92 on the top, the log of 8 on the bottom, and we get 2.1745. So 2.1745 equals m minus 7. We are solving for m, so we are going to add 7 to both sides. This becomes 9.1745 equals m. And there we go on that one, and that one's good. All right, on to problem 5. Now, we need to make sure that this is all alone. So I need to move the 4. Now, the 4 is multiplying right now, so we are going to do the opposite by dividing both sides by 4. We cannot identify the base, the exponent, or the argument until the base and the exponent are all alone. So 148 divided by 4 is 37. These cancel, so we're left with 7n equals 37. Now I can identify the base, the exponent, the argument, and change forms. So log base 7 of 37 equals n. Change of base formula, log of 37 over log of 7 equals n. Put that into your calculator. We have the log of 37 in the numerator, the log of 7 in the denominator, 4 decimal places, 1.8556. And that is n. And that one is good. All right, again, this needs to be all alone, means I need to get rid of this by doing the opposite, adding 5 to both sides. We get 4 to the 3w power equals 8. Again, base, exponent, argument. Change forms, log base 4 of 8 equals 3w. Change of base formula, log of 8 over log of 4 equals 3w. I'm going to put that in my calculator. Log of 8, log of 4, and I get 3/2, or 1.5. 1.5 might be better or easier to do. Divide both sides by 3, and w equals 0.75, or 3/4. Okay, those work. You can also do w equals 3/4. Either one of those work. Okay, all right, let's keep going. So 7 and 8 are very similar. Okay, we're just making them more complex. So I'm going to come down here and do, you know what, let's do 7. Let's do a little bit more complex, and then we'll go on and do maybe 9. All right, so all I want, base exponent, all alone. So the first thing I'm going to do is move this 7 by subtracting 7 from both sides. Okay, so I get negative 4 to the x plus 1 power equals 18 minus 7 is 11. I still want this all by itself. I have to get rid of this negative, so I'm going to divide both sides by -1. So now I have 4 to the x plus 1 equals -11. So here we go. Base is 4. Exponent is x plus 1. Argument is -11. Remember what I said. Arguments, I'm going to write it out here. Arguments cannot be negative. Okay, cannot be negative. So, this doesn't work. No point in changing forms because I can't have a negative argument. No solution. Okay, because of this. Okay, all right, let's see. We can do, let's see, we got a few. This is probably it for the day, so we'll do a couple of them. I'll do number 10. Okay, base exponent all alone. I'm going to subtract 7 first. So -2, 5 to the p, I want all that by itself, equals -70. Divide by -2, I get 5 to the p equals, negative is positive, positive 35. All right, here we go. Base, exponent, argument. Change forms. Log of 5 of 35 equals p. So then it's log of 35 over log of 5. I'm doing the same thing in every problem. In my calculator, I'm putting the log of 35 on the top, or in the numerator, the log of 5 on the bottom, in the denominator, and p equals 2.209. Now, I'm going to go over rounding real quick. I'm going to put this many numbers. I only want 4. I need to look at this 5th number here and decide, does the 0 stay a 0 or does it bump up to a 1? My answer is 2.2091. Okay, make sure you're careful with the rounding. All right, let's do another one. Let's do number 14. All right, base exponent. All alone. Subtract 10. Always add and subtract first in algebra before you multiply or divide. Okay, different for PEMDAS. PEMDAS you would multiply and divide first, but we have an equal sign here, so this is not PEMDAS, this is algebra. So subtract 10 on both sides. You get 3 times 8 to the 3 minus 7n. I still want this all alone, equals 84. Now, divide by 3. Now I have 8 to the 3 minus 7n equals 84 divided by 3, 28. All right, now we've got base, exponent, argument. Okay, change forms. Everything looks good. Log base 8 of 28 equals 3 minus 7n. Change of base. Log of 28 over log of 8 equals 3 minus 7n. I'm going to come over here. So in my calculator, log of 28 on the top, log of 8 on the bottom, and I get 1.6025. So 1.6025 equals 3 minus 7n. I'm going to subtract 3 minus 3. So 1.6025 minus 3 is negative 1.3975 equals negative 7n. Divide by negative 7. Divide by negative 7. And our final answer is 0.1996 equals n. All right. And let's check and make sure our argument is positive this whole time. It's perfectly fine. Check. We're good. Okay? As long as your argument is positive, your exponent can be negative. You just need to make sure you have a positive argument. All right, I gave you a bunch of different examples. Keep practicing. Ask questions in class. Let me know if you need any help.